The evolution of the Internet. Origins and inspiration. The story of the Internet begins amid the Cold War and the rise of computers. In 1958, after the Soviet launch of Sputnik, the U.S. government created the Advanced Research Projects Agency, ARPA, to help American military technology stay ahead of its enemies. ARPA's mission included testing the feasibility of large-scale computer networking. One visionary leader was J.C.R. Licklider, a psychologist and computer engineer at MIT, who joined ARPA in 1962. In a series of memos that year, he described an intergalactic computer network, a globally interconnected set of computers through which people could quickly access data and programs from anywhere. Licklider believed that if computers were combined into networks, the role of computing in society could be transformed. This seed of an idea, sharing information instantly across distances, set the stage for what would become the Internet. At the same time, researchers on both sides of the Atlantic were exploring robust communication methods. In the early 1960s, Paul Barron at the RAND Corporation, US, and Donald Davies at the UK's National Physical Laboratory each proposed a distributed, packet-switched network. Barron's motivation was military resilience. He designed a network that could keep running even if some nodes were destroyed by attack. Independently, Davies proposed breaking digital messages into small packets that could travel through a network via the next available route and be reassembled at the destination. This idea of packet switching, splitting messages into pieces, would prove essential. It makes networks highly efficient and fault-tolerant compared to traditional circuit-switched telephone lines. Inspired by these concepts, ARPA funded a project in the late 1960s to build a prototype computer network. Under ARPA's IPTO director, Larry Roberts, himself a protege of Licklider, the plan for the ARPANET emerged. In August 1968, ARPA contracted the company BBN to build special packet-switching computers called Interface Message Processors, IMPs. The first IMP was installed at UCLA in 1969, making UCLA's host, under Leonard Kleinrock's leadership, the first ARPANET node. Kleinrock, a UCLA engineer, had earlier proven the theory of packet switching by publishing the first paper on it in 1961 and demonstrating a small network in 1965. On October 29, 1969, UCLA graduate student Charlie Klein sent the first message over the fledgling ARPANET to a computer at the Stanford Research Institute, SR, literally typing the letters L and O before the system crashed. That truncated message, LO, heralded a revolution. As UCLA later reflected, Leonard Kleinrock was one of the key architects of the Internet, having developed the basic principles of packet-switched networks and overseen the first successful computer-to-computer message. In Kleinrock's words, the team had no idea how truly momentous an event it was when ARPANET came alive, but history would soon show they were right. Building the early network, after that first connection, the ARPANET grew rapidly. By the end of 1973, it linked over 30 institutions worldwide, universities, military labs, and even international sites in Norway and England. New applications emerged. In 1997-2, Ray Tomlinson at BBN sent the first network email, and researchers coined the term Internet for interconnected networks. Crucially, in 1974, ARPA researchers Vinton Cerf and Bob Kahn published a protocol for packet network interconnection, describing what would become the Transmission Control Protocol, TCP. This laid the groundwork for linking multiple networks into an internetwork. By the early 1980s, TCP and its companion Internet Protocol, IP, were adopted as the standard protocol suite. As the Science Museum notes, Cerf and Kahn's TCP/IP governs how data moves through a network and helped the ARPANET evolve into the Internet we use today. The Domain Name System, DNS, was introduced in 1983 to map human-friendly names, like .com and .edu domains, onto numeric addresses, making the network easier to use. By the mid-1980s, a dramatic expansion was underway. In 1986, the U.S. National Science Foundation created ENSFNet, a high-speed backbone connecting regional research networks and supercomputer centers. This effectively turned the Internet into a nationwide, and eventually global, grid of networks. With NSF support, university, and research users across the United States now had access to the Internet. The number of hosts, computers, online grew from thousands to millions during this era. Commercial services also began to appear. In 1989, the first public dial-up Internet service providers launched. By 1991, the network that began as an ARPA experiment spanned the world. The World Wide Web. In the late 1980s, a new development would take the Internet from a tool for researchers to a medium for everyone. At CERN in Switzerland, British scientist Tim Berners-Lee sought an easy way for physicists to share information across distributed labs. In 1989 to 1990, he invented the World Wide Web, a system of hypertext documents linked by HTTP, Hypertext Transfer Protocol, and written in HTML, Hypertext Markup Language. Berners-Lee also wrote the first web browser and server on a NeXT computer at CERN. The very first website, located at info.cern.ch, was dedicated to explaining the World Wide Web project itself. Berners-Lee's web was released freely. On April 30, 1993, CERN put the web software into the public domain so it could spread without restrictions. Almost immediately, the web exploded in popularity. Graphics-capable browsers like Mosaic, 1993, and later Netscape Navigator made it easy for ordinary people to surf from page to page. By the mid-1990s, the web had become the defining service of the Internet. Governments, the White House and UN, put up websites, online search engines, AltaVista, Yahoo, then Google in 1998, emerged, and e-commerce sites like Amazon and eBay launched. Throughout this boom, the core Internet protocols, TCP/IP, remained the plumbing, but the web provided a user-friendly interface. As sources note, the Internet is older than the World Wide Web, but the web gave everyday users a reason to go online. Tim Berners-Lee's invention turned a complex research network into a multimedia information space that transformed society. The Internet becomes global and social. By the late 1990s, the Internet was woven into daily life. Technical upgrades kept pace with demand. In 1998, the Internet Protocol version 6, IPv6, was introduced to vastly increase address space, anticipating future growth. Broadband technologies and wireless networking emerged, making connections faster and always on. The 21st century saw the Internet's role grow even larger. In 2004, Facebook was founded, ushering in the era of social networking. Within a few years, it had hundreds of millions of users, 100 million by 2008, sharing content online. Video sharing also took off. By the late 2000s, YouTube users were uploading around 500 hours of video every minute. New platforms, Twitter, Instagram, Snapchat, etc., let people around the world connect instantly with friends and share opinions. By 2012, global Internet traffic had surpassed 43 exabytes per month. An exabyte is a billion gigabytes. The sheer scale was astonishing, as Corning's history notes. Once cloud computing and social media took off, the cloud truly became computing, global network of data centers accessed by billions of users. Today, the Internet is a vast, global mesh of networks. Each node on the map represents a connection point, a server, router, or data center, and each line shows a data path along fiber optic cables, satellites, or wireless links. Advanced fiber optic technology carries most of the world's traffic. For example, in 2004, Corning introduced plug-and-play fiber-to-the-home solutions to expand high-speed access. Under the ground and oceans, high-capacity fiber cables carry terabits of data per second. Meanwhile, wireless generations have advanced rapidly. 3G networks were followed by 4G, LTE, and now 5G, each leap boosting mobile speeds and enabling new applications. Smartphones epitomize the Internet's ubiquity. When the first iPhone appeared in 2007, it combined a phone with a web browser and email, essentially putting the Internet in every pocket. By 2020, the majority of people around the world carried powerful Internet computers in their hands, using apps and browsing everything from news and video to social feeds. All of this mobile data is fused into the cloud. Businesses and individuals store data on remote servers, Amazon AWS, Google Cloud, etc., and access it from anywhere. As one analysis notes, modern cloud computing operates atop a global network of optical fiber lines. By the mid-2010s, cloud services, like Salesforce, AWS, Dropbox, had become the norm, generating billions in revenue and shifting the industry from owning servers to renting services. Social media platforms also exemplify the Internet's influence. Facebook alone grew to 2.5 billion users by 2019, and Twitter, WhatsApp, Instagram, and others connect people in real time. Users now produce a torrent of content. Consider that YouTube users now upload hundreds of hours of video every minute. These platforms rely on cloud architectures to store and serve content, on fiber networks to deliver it globally, and on the ubiquity of mobile connectivity to reach us anytime, anywhere. A world transformed. In conclusion, from its origins in military and academic research, the Internet has grown into the backbone of modern life. The work of early pioneers, Licklider's vision of an intergalactic network, Kleinrock's packet switching theory, and Cerf and Kahn's TCP/IP design enabled researchers to invent a global digital communication system. Tim Berners-Lee's World Wide Web made that system accessible to billions. Today's Internet, fast, mobile, and interconnected, shapes everything from how we socialize to how economies function. Fiber optic cables and wireless 5G towers make data flow at unimaginable speeds, cloud computing hosts our data and apps at a massive scale, and social networks let ideas spread instantly across the globe. In just a few decades, the Internet has gone from an experimental network in a university basement to an indispensable global infrastructure. It constantly evolves, supporting new technologies like artificial intelligence, the Internet of Things, and virtual reality, but its roots remain in the innovations of the 1960s and 1970s. As one historian put it, the first ARPANET message of 1969 truly launched the Internet revolution. That revolution now defines our modern era, connecting people and information in ways Licklider and Kleinrock could only have imagined.